Hello student, how are you? I'm Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the waves part 1. Student, in 2 class, I'll finish the whole waves chapter. Every theory required for NEET exam and IIT exam and class 11 school exam, every theory will be cleared. You don't require to send another video. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with good rank. Now let's start about the class. Okay. So waves generally divided as progressive waves. Progressive waves, that is waves moves with time, and stationary waves, that waves confined in a region. Progressive waves divided into two categories. One is longitudinal waves, and another is transverse. And stationary waves is formed by reflection from an flexible wall. I will discuss later in details what is flexible wall, what is rigid wall. So this stationary waves formed due to reflection from a flexible wall, and reflection from a rigid wall. What is flexible wall? This is a vertical support and a string is connected by ring, and if the string is oscillate, then the ring also oscillate, and this is the flexible wall. And if the string is connected rigidly fixed, this is a vertical wall rigidly fixed, and if you oscillate the one end of the string and this will rigidly fixed, then this is called rigid wall. If the ring is connected through the support and if you oscillate this, then the ring also will oscillate. This is called flexible wall. And if the string is rigidly fixed, it will not move. That is rigidly fixed. Not this end cannot move. So this is the rigid wall. Now what is longitudinal and transverse waves? Longitudinal waves is, suppose this is a tuning fork. When we strike the one arm, then this will oscillate in this way. This will oscillate in this way, and here the waves moves through compression and reaction. And so what is the longitudinal waves? The waves, the direction of the velocity of the waves, and the particle velocity, direction of particle velocity, that is small b. If the direction of the wave velocity and direction of the particle velocity parallel, then we call this is longitudinal waves. So every particle will oscillate about its mean position. Every particle oscillate about its mean position when an waves passes through the medium. So here the particle oscillate along the direction of the wave velocity in this direction. This and this is parallel. So this is called longitudinal waves. Now what is transverse waves? Transverse waves means oscillates about its mean position. Every water particle oscillates about its mean position and the waves move in this direction. This is the velocity of the waves and the particle velocity v. So if the particle velocity if the particle velocity is perpendicular to the wave velocity, this is called transverse waves. If the particle velocity is perpendicular to the wave velocity, we get the equation of waves. We find that the waves equation is the function of x and t. Two variables is present. Now in SHM equation was x equal to a sin omega t. Only one variable is present, that is t. X is the function of t, x or y. One variable is present, so x is varies with time. Now the waves equation, two variable will be present. Now first we find the equation of progressive wave, then we can understand easily that how the waves equation varies with two variables. Equation of progressive waves. Equation of progressive waves. Suppose here is a pond and we dropped a stone at a pond. We dropped a stone at a point. Where the stone dropped, this is the source of waves. So a waves is formed like this way. We know that this way waves is formed. This is water particle. This is water particle. In this direction also, this is the source of waves. Now if direction, so this is as x direction, this is x direction and this is as y direction. Okay, so every now this is the waves formed in a pond. Now this is not this is crossed, this is called crest and this is top, but this will not permanently present. After some time this will down and this will move upward. So this way the waves formed. This is the picture at one moment. This formed at point at instant. If we take a photo on the waves, then we get this. But after some time this figure will be changed. So this will come down and this will move upward like this way. So this way the every particle oscillate. So every particle oscillate about the mean position. This is the mean position. Now every particle on the how wave is formed. Every particle actually oscillates. Every particle actually oscillates about the mean position. Every particle oscillate about the mean position. So these particles, water particles, oscillate about the mean position, but the transmission of the motion take place. That is, every water particle present side by side, and motion is transmitted to the next water particle. So a energy is transmitted, and the motion is transmitted by one. Motion is transmitted one by one. So a waves is formed. But here particle is not transferred. Particle of here is present here. This particle oscillate about the mean position and its position is not changed. It will not move. It will not move in this direction. Only a transmission. Motion is transmitted. Motion is transmitted in this direction. So because every particle with adjacent to each other, so motion is transmitted to the next particle. So every particle will oscillate, and we see that a movement is transmitted like this way. But this particle is not moved in this direction. This particle oscillate in this direction, oscillate about this mean position. So particle will not move, but a movement or energy is transferred in this direction. This is called source. This is the source of waves where waves is formed. So this is the source of waves. In the wave equation, we take the position of source is at origin. So we take the source at origin and we take a point on the wave curve. We take a point on the wave curve which coordinate is x, y. Now what is x and what is y? We have to know what is x and what is y. What is x? X is position of the particle. X is position of particle from source along x-axis. This distance is x, and y is y coordinate. So we define as y is the distance of particle from mean position. We call y is the position of particle at mean position, and x is this distance. That is distance of the particle position of the particle along this along x-axis from the source. Now, so for every particle there is a value of x and also a displacement of the y is given here. Now we have to find the y, equation of y. We have to find the y in terms of x and t. So y is the function of x and t. This will be the wave equation. So how y is the function of x and t comes here. First, every particle oscillate in SHM. Motion, equation of motion at source. Equation motion at source equal to y equal to a sin omega t. where a is the amplitude. Now this particle oscillate after some time. So equation of this particle will be y equal to a sin omega t minus phi, because so there will be the phase, the less phase, the phase of this particle will be less than the phase of this particle, because when this particle starts, then this particle already moves some distance, this particle moves already some distance. So when this particle starts here, this particle moves already some distance. That is, now the displacement equation in SHM was x equal to a sin omega t. That is, as phase is more, then displacement is more. So as the displacement is more, as the displacement of the particle in left side is more than right side, so the phase angle of the left side particle is more than this. So this phase angle will be less than this phase angle, will be less than this angle, because now we have to express phi in terms of x. Now we know the lambda is wavelength. Suppose for a particle, when a particle describes in a circular path, total angle described is 2 pi in one time period, and one time period waves also move through the distance lambda. Waves move through the distance lambda. So for lambda distance, phase angle produced is 2 pi, and for x distance phase angle will be 2 pi by unitary method, 2 pi by lambda into x. So for the distance x, what is the phase difference? This will be the phase difference due to the distance x. So this will be the phi will be this. We find this phi due to the distance difference x, due to the position difference. So we find phi in this way. For lambda distance, the phase angle should be 2 pi. For x distance, phase angle should be 2 pi by lambda into x. So this will be the phase difference between this and this due to the position. This particle is at distance x from this source, So due to the difference of distance, the phase angle difference should be this. Now put phi equal to this at this place. A sin omega t minus phi equal to this x. So this is the equation of progressive waves. T is variable and x is variable, and y is the function of x and t. So in waves two variable will be present. In SHM only one variable was present, and in waves two variable is present. Now y, what is y? Y is the displacement of particle. Y is displacement of particle under the SHM, a particle in medium through which wave passes. Displacement of particle from in position. We always take the displacement from in position. Now suppose here is a particle and here is a particle. So the displacement of the particle from in position depends upon the position, because here y is this position, y is this. So due to the difference of x, position of y also, the value of y also depends. That is, y is the function of x only. Function of for time t, if we take the same particle, that is when x is constant. When x is constant means we consider the same particle. So same particle oscillate about the mean position. So at different time, this position will be different. So at a time the position is at here. After some time the position will be is at here. So at different time, the y value of y for same particle, x is same means for same particle. So after for same particle, because x is constant, displacement is the function of t and x. When t is constant, we consider at an instant different particle, that is particle at different position. The value of y is different, because if we take a photo, then this particle is at this position, this particle is at this position, so y is different. Now if x is constant, it means that we consider a same particle, so same particle oscillate, that is its displacement y is different at different time, y equal to a sin omega t. If we take 2 pi by lambda common, then 2 pi by lambda common, this becomes x minus omega lambda by 2 pi into t. So this will be a sin minus 2 pi by lambda x minus, what is omega? Omega is 2 pi n lambda, that is v into t. Now this v is, that is a sin v 2 pi by lambda into vt minus x. So y is the function of vt minus x, where v is velocity of waves. So velocity of any waves can be expressed in the function of vt minus x. Vt minus in this way, v is the velocity of waves. Now here omega, coefficient of t is called omega, coefficient of x is called 2 pi by lambda, which is k, which is wave constant. Wave constant. If we divide omega by k, now omega by k will be, omega is 2 pi n is frequency and k is 2 pi by lambda. So 2 pi cancel. So n lambda equal to v, that is velocity of waves. So velocity of waves formula is v equal to omega by k. This is a formula. Omega k. What is omega? Omega is coefficient of t, and what is k? K is coefficient of x, given by y equal to 10 sin 100 pi t minus 0.01 pi x. This find wavelength, velocity of waves, etc. So what is the solution? Solution will be, if you compare an amplitude of the waves also, this is called amplitude, we know. If we compare this, a is amplitude and coefficient of t is this and coefficient of x is this. Find the wavelength. To find the wavelength, we have to equate coefficient of x. Coefficient of x is 2 pi by lambda, so this equal to, from this we cancel pi and lambda equal to 2 by 200. Then x is in meter, it is given. X is in meter, it is given. And what is omega is coefficient of t, and omega by k, this is k and this is omega, so omega by k, this is the answer. You have to find in this way. By comparing this, you get. So always remember, coefficient of t is omega and coefficient of x is k. K means wave constant, 2 pi by lambda of two particles. Next topic is phase difference of two particles separated by a distance del x in the waves. Two particle is in the waves. If the distance between two particles is del x, then what is the phase difference? This is A, and second is after phase difference, after time del t with time. So equation of solution. So equation of progressive waves is y equal to a sin omega t minus kx. K is wave constant, kx. This is the wave equation. Now this is called the phase. This is called the phase. This is phase of particle. Now this phase phi omega t minus kx depends on time and distance also. So when x is constant, when x is constant, what is the change of phi? Del phi equal to, we can write omega into del t. Del phi equal to omega into del t, because x constant means is change is 0, and so this is one formula. And when t is constant, and when t is constant, then t is constant, then del phi equal to minus k into del x. When t is constant, this change is 0. Constant means its change is 0. So del phi equal to minus k del x. So this is the formula. So separated by distance del x, we write this formula, and for time del t, the change of phase will be this. Progressive waves. Equation of progressive waves is given by y equal to 50 sin this is find the phase difference of two particles. Find the phase difference of two particles separated by distance 50 meters. So what is the solution of this question? So solution will be two particles separated by distance. Here del x is giving, distance is 50. Now what is the formula? Del phi equal to minus k. So this is k, 0.0035 into del x equal to 50. So this is the answer. Okay, change of place. So if we take the magnitude, then this is the answer. So we find k, and this is omega. So del phi equal to this. Particle displacement, relation between particle velocity and wave velocity. What is the relation between particle velocity and wave velocity? So this is x, this is y, and xy. So displacement of y equal to, equation of progressive wave is y equal to a sin omega t minus k into x, where k equal to 2 pi by lambda wave constant. Equation of progressive wave equal to this. If the waves moves towards the positive x, then the waves equation is written as this. Now if the waves moves in this direction, the equation is written as omega t plus kx minus or minus x. If the waves moves in this direction, velocity of the waves in this direction, then the waves equation will be this. And if the waves moves in this direction, wave equation is this. Here we take minus or minus x, that is plus x. Now what is y? Y is the displacement of the particle, that is this particle. Displacement is denoted as y. Now to find the particle velocity, we have to differentiate y with respect to t. That is dy by dt equal to velocity of particle. So dy by dt equal to part a omega cos omega t minus kx. Dy by dt equal to coefficient of t is omega. So here you know the differentiation. A omega derivative of sine is cos. So this sine theta cos theta, and coefficient of t is omega. Omega is at here. This is the velocity of the particle. So maximum velocity of the particle will be v maximum. Maximum of cos is 1. So a omega. A is here not acceleration, A is amplitude. Here A is amplitude. Okay. Now we have to find the dy by dx. So this is the velocity of the particle. A omega v equal to dy by dt. For this now, if we differentiate with respect to x, dy by dx, what happens? Minus a k cos omega t minus kx minus a k cos this. Now dy by dt equal to this. This is equation 1 and this is equation 2. If we divide it 1 by 2 divided by dy by dx equal to a omega by minus a k. Now this is velocity of the waves v. So from this we get v by capital V equal to minus dy by dx. So this is the relation, velocity of particle to the velocity of waves. This will be the relation. What is v? V velocity of particle and capital V velocity of waves, and dy by dx. What is dy by dx? Dy by dx equal to slope of tangent to the wave curve. Slope of tangent to the wave curve. So this is the relation. So velocity of the waves, suppose in this direction v. Now velocity of the waves, velocity of the particle in this direction, and dy by dx is the slope of the wave curve is this. Now this angle is theta, suppose. So this angle will be pi minus theta. Now slope of the tangent of the wave curve. This is the wave curve. Slope of the tangent. This is slope. This is the tangent. The slope of the tangent is tan pi minus theta. This is pi minus theta. So minus tan theta. Suppose this angle is theta. Now this angle is pi minus theta. This angle is pi minus theta. So slope of the tangent is tan pi minus theta, which is equal to minus tan theta. Now what is tan theta? Tan theta equal to, from this triangle, tan theta equal to, this is perpendicular v and this is base v, small v. So tan theta equal to v by small v from this triangle. This and this. From this triangle, this we get tan theta equal to, this is theta. Tan theta equal to perpendicular. We get from this tan theta equal to perpendicular. This is v and base is capital V. So from this figure you also get small v by capital V equal to minus dy by dx. Sound velocity. Velocity of sound. It is found that velocity of sound through any medium equal to elastic modulus by its distance. Where is elastic modulus of any medium? Velocity of sound through any medium equal to this formula, elastic modulus of any medium. Velocity of sound through string equal to, formula is root over T by mu, where T is tension of the string, and mu equal to mass per unit length. So two formula of velocity of sound, any medium, solid or gas, the velocity of the sound will be root over e by t, and through stress string velocity of sound is t by mu. These are the two formula. Now this is important in class 11 school exam. Velocity of sound in air. So air is a gas. So first we derive Newton's law of velocity of sound. Newton's law of velocity of sound in air. Newton's describe that according to Newton's sound travels through medium. In isothermal process. That is no change of temperature take place when sound waves moves through the medium. In isothermal process. So in isothermal process, gas equation is PV equal to constant. PV equal to nRT is the gas equation, T is constant. Now when sound waves moves, the air contracts. When sound waves moves, the air contracts. That is pressure increases. The pressure of air, pressure increases and volume decreases. Let initial pressure is P, volume become P, and final pressure increases P plus del P. So that's why volume decreases, V minus del P. That is when pressure increases, volume decreases, and when pressure is low, then volume increases. As this is initial condition, this is final condition. So P into V equal to P V minus P into del V plus del P into V minus del P into del V. Now del P del V is negligible. Because negligible. This is small change. This is a small change. So the product of two small quantity is negligible. Now this cancel. So we get P into del V equal to del P into V. So P equal to del P V by del V. That is del P by del V by V. Now what is this expression? This expression del P is the excess pressure. So and this is volume strain. Volume stress by volume strain is denoted by B. B is what? Bach modulus. So velocity of sound in air will be Bach modulus by density. Now B equal to what we get from by according to Newton's formula, B equal to P. So P by D, pressure by density. Now velocity of sound is from Newton's law, it is root over P by D. So this is Newton's formula of velocity of sound in air. But if we calculate the velocity of sound, then this becomes 280 meter per second, but actually it is 340 meter per second. So something is wrong here. Some factor is present here which is found by the Laplace. So this is not correct. We cannot use this. We don't use the formula of velocity of sound. This formula. This is Newton's formula. Sometimes this formula comes in school exam. So I have shown this. Now what is Laplace formula? velocity of sound waves travels through medium in adiabatic process, that is when sound waves travels through medium, temperature of medium changes. Now adiabatic process, what is the gas equation? Gas equation will be P v to the power gamma equal to constant. P v to the power gamma equal to constant, where gamma equal to ratio of two specific heat Cp by Cv. Now, so if the pressure V increases, then volume V decreases. So in two cases, suppose initial pressure is V and initial volume is V, final pressure is P plus del P and volume becomes V minus del V. This is the initial condition, this is final condition. If we simplify this, if we take common P, we get del P by P, and if we take common V to the power gamma, take common P, then this becomes this. Now cancel P, V to the power gamma, P, V to the power gamma, we get by binomial expansion, del V by P is small, this small quantity. So what is the expansion of 1 minus x whole to the power n? This becomes 1 minus nx plus n into n minus 1 by factorial to x square plus something x cube, etc. So x equal to del V by V. As x is small, then this is higher power of x is negligible. This becomes negligible, so we only take this value 1 minus nx. So this is n and this is x. So 1 minus nx, the result is 1 minus nx. So I write here 1 minus nx. Now if we multiply this, what happens? What comes? 1 minus gamma del P by P plus del P by P minus gamma del P del V PV. Now this will negligible. This will negligible. Now 1 equal to 1 cancel. So here we get gamma del P by V equal to del P by P. So gamma P equal to del V by del V by V. Yes. Gamma P equal to del by V. Gamma P equal to del P by del V by V, which is Bach modulus. So from Laplace theory we get Bach modulus equal to gamma P, not P. Here a factor gamma is present. Now so Bach modulus is equal to this. So now velocity of sound equal to root over Bach modulus B by D, which is root over gamma P by D. D is density of air or gas or any gas. If velocity of sound through any gas, what is the relation? What is the effect of temperature, molecular weight, and what is the effect of temperature and molecular weight of a gas on the velocity of sound? From this we get velocity equal to root over gamma P. Now what is density? Density equal to mass by volume. D equal to mass by volume, m by P. Now what is PV? PV equal to nRT. Now what is N? Which mass mass equal to number of moles into molecular weight. We know number of mass equal to mass of any gas equal to molecular weight into number of moles. If a gas contains n moles and its molecular weight is capital M, what is the mass of the gas? Number of moles into molecular weight, you know, that is NL cancel. So formula becomes Vs equal to root over gamma RT by M. So this is the formula of velocity of sound in any gas. So here T and M, two variables are present, T and M. So for different gas has different molecular weight, and for different temperature the velocity of sound also different. We get two formula. Velocity of sound is proportional to, one is root over T if M is constant. M is constant means same gas. If we take the same gas, then for same gas molecular weight is constant. Now for same gas at two different temperature, velocity of sound will be different. Now velocity of, so this is the formula now. And also velocity of sound is inversely proportional to root over M. So for two gases at same temperature, velocity of sound will be proportional to square root of molecular weight. Velocity of sound at T degree centigrade equal to what? Velocity at Vt equal to velocity of sound at T degree centigrade. What is the value? We know T equal to T plus 273 Kelvin. This is for Kelvin temperature. This is Kelvin temperature, Kelvin scale. T equal to T plus 273 Kelvin, and for 0 degree, T0 equal to 273 Kelvin. 0 degree centigrade. 0 degree centigrade means 273 Kelvin. Now Vt by V0, we get Vt by V0 equal to root over V by T0, which is T equal to this by 273, which is 1 plus T by 273. Vt equal to V0 into 1 plus half. So this value is, this is the fraction power. So expansion will be first T, then T square, T, etc. So we get just we use just 1 plus x whole to the power n equal to 1 plus nx. Higher power of x is less than 1, then half nx. So this is the Vt, velocity of sound at T degree centigrade. V0 is velocity of sound at 0 degree centigrade. At 0 degree centigrade. Students, this is the end of the class today. To watch the remaining part of the waves, watch my another video, waves part 2. Okay, thank you.